Big gold nuggets. That's something everybody wants to find. I have here a handful of big gold nuggets. Here I'm trying to hold it so that you can see it without them falling off on the ground. This is a handful of nuggets that I've found with my metal detectors over the years. I have more than just this, but I selected out these because they look nice.
And here's the close-up of my handful of big nuggets. You know, this is the kind of stuff that gets prospectors fired up. And I got to tell you, with every single one of these finds, I was really fired up and excited. It makes you want to get out there and really, really search for the big stuff, the big finds. And I mean, this is, at current prices, about $10,000 in the handful there.
Big gold nuggets are exciting to find, and that's what we're going to talk about today. The geology of big gold nuggets. Gold nuggets, man, every one of these has a memory and a story that goes with it. And I've had so much fun finding them. I mean, I wrote my book, Fistful of Gold, and here it is, a fistful of gold. But I want you guys to find it. Now, what am I going to use for a definition for big gold, right? You know, is it a couple of grams? Yeah, you know, it's kind of arbitrary, but for the sake of what we're talking about today, I'm going to say it's stuff that's 1/4 of an ounce or more. So we're talking, say, about 8 grams or more. And these are all well over. And in fact, you know, it's pretty exciting to find these. And they really are valuable. And, you know, a lot of guys will tell you, yeah, that's nobody ever finds stuff like that. But that's not true. I want to show you some finds that have been made by other people, friends of mine and stuff, just to let you know there's still big gold out there to be found. And if you learn something about the geology and you go to the right places, you can be one of the ones that find big gold too. So let's take a look at some big gold finds because they're just exciting.
This is a 7.5 ounce nugget that some friends of mine found in the North Fork of the Yuba River a few years back. This thing was so huge, the scales they had, it wouldn't even weigh on there. So they needed to go to the butcher shop. It's got great character, just enough rough beauty to it that it's an amazing nugget. Here's a nugget I found just this last summer in 2024. It weighs a little less than 1/2 ounce, but still, that's a really nice, healthy, good-sized nugget. Here's another nice piece of gold I found this summer with my metal detector. It actually wasn't that far away from the one I just showed you. This guy weighs well over 1/4 ounce, but not closer to 1/2 ounce. It's still a very nice piece of gold. Here's another nugget a friend of mine found a few years back in Northern California. This nugget weighs 9.4 ounces. That's a lot of gold and certainly enough to get you fired up. Here's some nuggets found by a friend of mine in Arizona. All of these nuggets are more than 1/4 ounce. The big one weighs 9.1 ounces. That's a lot of gold. This big, beautiful chunk of gold was found with a metal detector in Alaska years ago. It weighs 33 ounces. And although this isn't me in the picture, I did get to hold this nugget in my hand when it was for sale at the Tucson show. This giant nugget weighs 75 ounces and was found with a metal detector by a friend of mine in Northern California. Now, sometimes people get this confused. There was a 98-ounce nugget that was found, or supposedly found near Washington, California. That's not this nugget. This one weighs 75 ounces, and there's never been any problem identified with this nugget. It really was found in Northern California in recent years with a metal detector. Now, this is the largest nugget I know of that was found with a metal detector in California. This thing weighs 156 ounces and was found in the Randsburg area in the 1970s when metal detectors were just a shadow of what they are now, much less powerful and much less capable. But yet, this thing was close to the surface, and of course, it's huge. And so the metal detector screamed, and it was quite a find and caused quite a stir at the time. Now, this thing is really a boulder and not a nugget in any sense, But this boulder weighs over 100 pounds, but is estimated to contain more than 300 ounces of gold. Now, this thing sat by the side of a road for, I guess, for decades, until a guy on a bulldozer came by and turned it over and exposed the gold. Because on the other side, from what you can see here in the picture, there's not really any significant gold showing. And once it rolled over, of course, the gold was revealed. And imagine, it sat by a road for years. There's still big gold out there to be found. And of course, I'd be remiss if I didn't toss in some Nevada gold from my home state. This is about 70 pounds of gold taken from a mine, and I'm told that when they took this picture, they had two big strong guys help the lady get into position for the picture and hold the pan and get her set, and then the two big guys stepped out of the picture and they took the photograph. And she's holding 70 pounds of gold in that pan. So I hope that this has kind of fired you up a little bit and got you the idea that there's big gold out there to be found, and it's exciting and it's worth going after.
You know, just looking at pictures like that can really give a person a case of gold fever. And they're exciting. And, you know, to know that that stuff is out there to be found is just really amazing. And it's worth the time to learn about the geology of big gold so that you can go out and find some for yourself and make some memories for yourself and find your own fistful of gold. In this video, we're going to talk about the geology of big gold nuggets, how they form, where they come from, and we'll talk about the places that you guys can go out there and look for them and make some really great finds for yourself. Now, the first thing I want to talk about is that all placer comes from hard rock sources. So yes, you know, it's always some sort of a hard rock. It's not always something that looks like a quartz vein. There are things where I found gold. Some of that gold I just showed you, a couple of those pieces, came from places that really, you would not look at that and say that's a quartz vein. They come from places, it is a shear zone, it is an area where there's faulting and stuff like that, and there is some quartz in the area, but the gold really isn't coming, you know, sometimes it is right in quartz veins. I'm not saying that it's not that way, but sometimes it's not. It's not always in a quartz vein, but it is always in a hard rock source that gets eroded and broken down over time as the hills and mountains wear down. The forces of wind and rain and water and gravity just erode these rocks away and release the gold that's in them. Now, I say originally comes from hard rock sources, but there are times when placers are formed from reworking of older gravels. And, you know, like moraines or other river gravels, or something gets uplifted and more eroded, and so you have a placer that was in an older gravel gets eroded and reworked, and lighter materials get washed downstream, and you reconcentrate the gold. This especially happens in moraines where, you know, the glacial process just stirs up the gravel and dilutes it down to where the gold is just a tiny percentage, and then the reworking of those gravels and washing off of the lighter materials reconcentrates the gold. So whether it's from reworked gravels or just directly off the side of a hill, all gold, at least originally, comes from some kind of hard rock source. Let's take a look and talk about that some more.
The big coarse gold often comes from rich pockets like this in an underground mine. This is actually in Australia, but you can see it's a small vein, less than 10 inches, and it's where the vein is broken up. It was not able to continue through. You can see the vein continues and breaks and then steps over and continues above. But this kind of really coarse pockety stuff often yields really big gold. An extraction of rich pockets like that yields specimens like this, and you can see this is the kind of thing that would yield big pieces of gold and gold quartz specimens that were really amazing. But whether it's a rich pocket, a coarse gold, or whether it's just fine gold, you know, all the gold in placers originally at one point came from some sort of hard rock deposit like a quartz vein or something else. And as the hillside erodes, it breaks up and the gold is released, and it eventually makes its way down into the stream and river gravels.
Now, all of these hard rock sources, or virtually all of them, there may be a small percentage that aren't, they're hard rocks that don't come from this type, but almost all hard rock source comes from actually dissolving the gold in hot waters. Now, you may say to me, hey Chris, I dropped my ring once in some hot water and guess what? It didn't dissolve, okay? Gold doesn't really dissolve in hot water. Well, yes and no. Because yes, if you had water, if you had, a cup of hot water that you got out of your teapot and you dropped a ring in it, yeah, it isn't going to dissolve. But if you have the right kind of water under the right kind of conditions, actually the gold can dissolve. Sulfur, which is a naturally occurring element, can dissolve in water, and you get, sulfury waters and that kind of stuff. And if you get really hot, sulfury water at temperatures well above boiling, like 300-400 degrees, maybe even a little more, that kind of stuff, that hot sulfury water under pressure, because the only way you can have water at 300 and 400 degrees is to hold it under pressure. It actually can dissolve gold. And the natural hard rock deposits that our placers come from are basically natural processes that take gold out of rocks and other things and concentrate them into veins or other deposits of gold that we can find. And so this process, it's a natural process of heat that comes from, deep in the earth. And it's just the chemistry of gold that hot water with a little bit of dissolved sulfur in it can actually dissolve gold out of rocks. And so it's very common. Most rocks have at least tiny traces of gold, and by that I'm not talking about specks you can see. I'm talking about parts per million or parts per billion. Actually, most rocks have some gold in the form maybe 3, 4, or 5 parts per billion. And so we're talking about, if you have a mountain of rock, you have a little tiny bit of gold, but you'd have to, it costs way more than the value of gold to get the gold out of that mountain of really low grade rock, super low, not ore grade, but super low concentrations. But this natural process of circulating hot waters can actually, the circulating hot sulfury water can actually dissolve the traces of gold in the rock and then move to reconcentrate it in some place where it becomes a valuable hard rock deposit, like a quartz vein or like some other type of deposit. But still, it's the natural process of these hot circulating waters that do this. Let's take a look. Most people are familiar with places like Yellowstone. Let's take a look at stuff like that.
For the nearer types of gold deposits that form nearer to the surface, it's likely that many of them would have this kind of a display going on the surface, hot springs, even little geysers and that kind of stuff like this. And one of the things that you can't see in this video, or you can't note in this video, is how much sulfur you can smell in the steam. It just really reeks of sulfur. And that circulating hot water deep down is forming veins and other metallized mineral deposits. Now, the gold and silver zone is down, a good depth, 300 meters, 400, 500 meters. And by the time it gets to the surface and you see those hot springs like that, yeah, there's still sulfur in the water, but the gold and silver and even some of the lighter metals that come out last, like mercury and antimony, that would come out nearer to the surface, even they're gone. You just see the steam, the hot water, and of course you smell the sulfur. But this is what an epithermal type of system would look like, with a shallow heat source, maybe molten rock or newly newly solid rock that's still really hot is causing the hot water to circulate and flow through fault zones above it. And if the conditions are just right, 1,000 or 2,000 feet down below the surface, you're forming super rich gold deposits like this.
Now, I mentioned that the water can strip the gold out of these traces in rocks, but there's also concentrations of liquid that can come from magma. Deep in the earth, there's actually a small percentage of water in those rocks, and that's why when you have volcanoes and you see stuff shooting up way up in the air like these lava fountains, it's when the steam that's in the rock comes close to the surface, and of course it boils and turns to steam, that stuff just comes flying out of the vent of the volcano, and you get these lava fountains as that steam is released. Well, deep underground, that steam is maybe still water or some form, and that stuff can have gold dissolved in it too. And because it again is hot, sulfury water, sulfur and volcanoes go together, and so you get that hot sulfury water, that water that comes off of magma, not shooting up into the air, but coming off the magma. If it doesn't ever make it to the surface, that liquid doesn't, it separates from the rock. The rock wants to, separate from that like oil and water. And so that liquid can contribute to forming. So you get both magmatic sources of gold where you have, the steam and liquid coming off of magma. That can be a source of gold. And then also this stripping process. And that's how the gold gets into the veins and other systems that we're familiar with. Now, to drive that circulation, to heat the water up and to drive the circulation, you have to have some sort of heat. And so it's the natural process of, heat, hot things rise, and as stuff gets heated, it wants to rise up. And so you have different kinds of heat sources. One of them we just talked about, magma, molten rock in the earth. Certainly that's a heat source, and that is a heat source that does drive some types of gold systems, gold deposits. Another one is just the heat gradient of the earth. You can actually have, if you go down deeper and deeper and deeper and deeper and deeper into the earth, it starts getting hot. Just not far from here at Virginia City, when they were mining down at depths of 4,000 feet, the rock there was 120 degrees, and they had a hard time having miners in there to work in that kind of a hot, steamy 120 degree environment. Imagine working in that. But there's a natural heat gradient as you go deeper and deeper. And so the depth that these deposits form at is actually often quite deep. Now, the shallower ones may be a few thousand feet deep, but the really deep ones may be as deep as 5 miles deep and even more. So some of the deposits really do form very deep, and it takes a long time for the uplift and erosion to release that gold into a system. And at those great depths, there really are tremendous pressures. And so the water is kept at a liquid even when it's really hot, just because, it's almost like a pressure cooker, a steam cooker, where you can heat water a little hotter than boiling by keeping it under pressure. Well, under huge pressure, you can heat it a lot more than boiling. And so deep down, these systems where the veins are forming, where the gold is depositing, it's a long ways down and under a lot of pressure. So we've got these hot waters that have dissolved gold out of the surrounding rock, or have taken up magmatic waters as a part of their mixture, and have taken up gold from those sorts of things. And so then where does that water go? How does it get deposited? Well, it's faults and shear zones that allow water circulation. You might say, hey Chris, water just doesn't circulate through solid rock very well. And you'd be right, it doesn't circulate very well through solid rock. Maybe a little tiny bit, but not much. It's these faults and shear zones that are the the water, the conduit for the water to circulate in. And that's why, quartz veins often look like fault zones, and they often show signs of having moved. You may have something in a quartz vein called a slickenside, and this forms when you have movement and you literally polish the rock, because the rocks move across each other and they literally, shine each other up, and so you have this sign of movement called slickensides. It shows you which direction the fault has been moving. The other thing they have is shear zones. Like I said, not everything looks exactly like a quartz vein, and sometimes when you have offset, instead of having a one line fault zone, you have offset fault zones. They actually connect to each other, but there's a broken zone between this leg of the fault zone and that leg of the fault zone. There'll be a broken zone in between, and that's sometimes called a shear zone. Now sometimes you will have a single fault and you'll have parallel breakage next to it, and those can be shears as well. And it's just shearing of the rock and breaking of the rock, again opening the rock up so that the water can circulate, and then it comes out. Then you have a situation of, how does the gold come out of the rock? Well, let's take a look more at faults and shear zones and some examples of that and how those work.
When you have one body of rock moving in a different direction because of faulting, because of pressures, you have a broken zone in between. And there's a fault core that's marked in the darkest that it gets the bulk of the broken rock, but then there's damage zones alongside. And oftentimes those damage zones will lead to something like alteration in the adjoining rock. You get some mineralization, maybe trace mineralization, but the real vein and the real mineralization occurs where the most water flow is, which is along the core of the fault. And, the idea that two different kinds of rock brought together by movement on a fault is a very common indicator for potential gold deposits. This little diagram shows why two different rock types connected by a fault is often the case in a mineralized fault zone. You can see the way this diagram is drawn, because this is a cut vertically through the earth, that the yellow and green layers are dropped down on the left-hand side relative to the right. And so at the very surface, you have the yellow marked rock type with the pink marked rock type. And it's not because that there isn't a connection, it's because that the left side has been dropped down. And so you have different types. And this is the kind of thing you see with a mineralized fault zone. Now, just to be sure, just having two different rock types come together doesn't mean there's going to be a gold deposit. But in areas that are mineralized and areas with mineralized faults, it's very common that you do have gold associated with faults that bring two different rock types together.
So with all this discussion of gold and sulfur, it shouldn't be any surprise that gold is commonly found with sulfur minerals. Yeah, no, it's not unusual that gold will be found with pyrite or galena or arsenopyrite or chalcopyrite or some other less common sulfide mineral. But the sulfur that carries the gold kind of has to go someplace, right? And a lot of times it ends up with iron, because sulfur and iron like each other, and so you end up with pyrite or marcasite or some other iron pyrite mineral like arsenopyrite. That's basically sulfur, arsenic, and iron to make arsenopyrite. So it's very normal that gold is commonly associated with sulfur minerals. And then, when the pyrite weathers, the pyrite will turn to iron oxides and stuff. And so that's why, as a general rule, that mineralized quartz with, iron minerals or iron staining, if, that sort of thing, mineralized quartz is more likely to have gold in it than just barren white quartz. And sometimes you'll have veins that have both. You'll have a vein that part of the vein is just barren white quartz that has hardly any gold in it. And maybe on the footwall or the hanging wall, you'll have a zone of mineralized quartz, and that's where all the gold will be. I know of places like that both in Nevada and in California. If you hunt the barren zone, you're just not going to find anything. But if you hunt the footwall or the hanging wall or wherever the mineralized quartz is, that's where the gold is going to be. But getting back to the idea of big gold nuggets, okay, we've talked a little bit how gold and gold nuggets form, or gold gets carried in the system and deposited in a quartz vein or a shear zone or something like that, and the minerals that might be found with them. Well, what about big gold? You know, why is some gold small and other gold big? Well, there's a lesson to this. And I have some crystals to show you of other minerals other than gold, but to grow any kind of crystal takes time of any size. If you are growing microscopic things, you can do it that fast. But if you're just growing stuff that gets bigger and of bigger size, it's true for whether we're talking about minerals like beryl or quartz or tourmaline, or whether we're talking about gold. In all those cases, it takes a stable, ongoing, long-term situation to slowly grow those minerals bigger and bigger and bigger and bigger. And I'm going to take a look at those in a second, but first you're going to say to me, Chris, hey Chris, you know, I recovered gold for years and most of my gold is lumpy, kind of round, you know, it doesn't look anything like a crystal. And you know, of course, gold that gets tumbled around in a river is going to be lumpy and round, but gold that isn't is more jagged. But actually, even your lumpy round gold, if you were to cut the nugget open and etch it properly, you could see all the crystals on the inside. So let me show you the inside of what a gold nugget really looks like as far as crystals, and then we'll talk about the growth of big crystals in slow, stable, ongoing conditions where whatever crystal or crystals has a chance to grow and grow and grow and grow because there's time and stability for the continued growth and you know, growth larger and larger and larger. Let's talk about that and let me show you some pictures.
This is actually what the inside of a rounded, blobby-shaped piece of gold looks like if you cut it and etch it so that you can see the crystals. And you can see the big blobby piece of gold is an interlocking set of different crystals and stuff. The dark brown stuff is quartz or some sort of rock, and the metallic is the gold. But even whether it's, you know, small interlocking crystals or something really big, a single crystal, it still takes time to grow a bunch of crystals that interlock like this. Here's some really giant quartz crystals, smoky quartz crystals. These things are about 1 foot in diameter because this is a standard size pallet. And, you know, it would take a long, long time at stable growth conditions to grow big, giant crystals like this. And the same goes for gold.
So you might ask the question, okay, Chris, what about big gold and little? And the truth is, and a lot of you guys will know this, that in most big quartz veins, that are mined on a larger scale, you know, mined commercially in the past, maybe in the 1800s, maybe even now. But most of that stuff is very fine grained. You know, the gold is like dust, or, you know, at least smaller than, you know, a few millimeters. Those are the big pieces. A lot of it's less than 0.5 millimeter, real small little gold, which is why, you know, the little gold, you know, in a lot of places they do a gravity separation to get out any coarse gold that may be in there. And in this case, I'm talking about stuff that's, you know, 1/8 of an inch, 1/16 of an inch, 1/32 of an inch. That's the coarse stuff. And the most of the gold then goes to cyanide. To be cyanide, you really ought to have something like 150 mesh and smaller so that you can dissolve the gold in a reasonable amount of time. So a lot of the big hard rock mines, they're producing stuff that's the majority of it, which is 100 mesh and smaller, 150 mesh and smaller. And so, you know, you have big gold from big veins Well, what about the big gold? You have little gold in the big veins. You actually end up having bigger gold in little veins. And so it works out that in fracture zones and other places where the flow is big in the big veins, you have all this turbulent flow, and it's not the stable conditions that it takes to grow big crystals. And so you have in the backwater, in the periphery of the vein, you generally have more stable conditions, and you can grow those bigger crystals. That's why a lot of pocket districts where you have coarse gold with pockets and that kind of, the veins are little tiny, and comparatively anyway. And you actually have some places where you have both in the same general area. A great example of this is the Randsburg district in California, in Southern California in the desert. You have some places where you have big veins, and you have very small gold that these things produced, but you have some other areas where the veins are smaller and more spread out, and they're little, and those are actually the places that produce the coarser gold, the big gold nuggets. The Stringer district, is famous for having produced 156 ounce nugget. Let me show you a picture of that. Maybe I showed it to you earlier. I'll show it to you again. The picture of the nugget from the Stringer district. And so, hardly don't get bigger than 156 ounces, at least not very commonly. And so that's a great example of a situation where in some places in that district you have big gold, and other places you have little gold. So let's talk about that.
I did show you this nugget, but it's 156 ounces and comes from a district where part of the district has big, wide, several feet wide, 4, 6, 8 feet wide veins and produces little tiny gold. And another part of the district called Stringer, because the veins are little tiny stringers, produces the coarser gold. This is a diagram from a mine in California where the vein crosses a little iron-rich kind of fault break zone, and the vein is offset a little bit, but there where the vein is pinched off and where it meets that iron-rich zone, you had a big deposit, a big pocket of coarse gold. Compare that to this real life vein from Western Australia, and you can see the vein, it's narrow, it's about 8 inches maybe. It's been broken off and cut off, and there where you cut off the vein, you have a rich pocket of gold.
So we've talked about how the gold gets dissolved in these hot sulfury solutions. Well, how does it shake out? How does it come out and get deposited as big coarse gold? Well, the gold can come out from a variety of reasons. One of the sources that produces real tiny particles of gold is boiling. I mentioned that these water solutions with gold in it are held under pressure deep in the earth. Well, as they get closer and closer to the surface, the pressure is less and less. And there actually can happen that the solutions start to boil and the gold comes out right away. And there are actually textures that geologists recognized as boiling type textures that indicate that the fluid boiled and then the gold, if there was any in the solution, deposited right away as tiny particles. But we're not looking for tiny particles, right? We're looking for big gold nuggets. So that's not the kind of situation that you want to find for big gold. One of the other things is changes in wall rock or chemistry. The old timers in California and the similar situation in Australia had situations where the veins would cross an iron-rich zone in the country rock that the vein was in. And the chemistry of the gold-bearing liquids would react with that iron-rich zone in the country rock. The old California timers called them iron crossings. And the gold would just drop out, and you would often have a super rich pocket. And I actually have a drawing that I want to show you in a second from both California and Australia of the same kind of thing and the super rich pockets that the miners found there. But changes in chemistry, the wall rock, you may go from being a mostly silica wall rock to being a mostly limestone wall rock. Or you may have changes in direction, rolls in veins often lead to deposition of high-grade gold and rich gold ore and coarse gold. So you have a vein and it kind of rolls over and goes back up. There's something that happened that changed direction. So changes of direction can be big indicators for high grade. And then another one is where the vein splays out. Literally, you may have a vein going on and then suddenly it splays out into a whole bunch of little veins. Remember I said little veins often have that more stable situation that leads to growing coarse gold. So let's take a look at some diagrams of that and talk more.
I showed you the California one just a minute ago, but here's the example diagram from the Bendigo district in Victoria State in Australia. You can see that from A down to B, this is the iron-rich zone, and where the vein crosses it, the CD is the vein, the gray is the vein, and where it crosses it, it's got a supreme enrichment in gold. And in Victoria, these are called indicator leads. It's basically the same thing as in California, where it's an iron-rich zone. In California, they call them iron crossings. But anyway, same thing, where a change in the wall rock shook out the gold.
Another thing I want to talk about is how the fluids in these things change over time. It actually, it isn't that the same kind of fluid flows through to form a vein just from start to finish. Oftentimes, and it doesn't always work out this way, but a huge percentage of time in a lot of different kinds of deposits tend to work out a certain way that the initial fluids that come through are quartz rich and gold poor. A lot of guys get the idea that somehow quartz is necessary for forming gold deposits, and the quartz isn't. It's just along with, in the hot water, it's along for the ride. There are places, and I've been to places where there's hardly any quartz. There's almost as much gold as there is quartz, because there's hardly any quartz. So it doesn't necessarily, gold does not require quartz. Iron is more important to gold than the quartz. So, the quartz is just kind of along for the ride. And a lot of times the initial fluids that flow through, that form a vein, are rich in quartz and poor in gold. And a lot of times you even can get pulses. We're going to look at that in a second. I'll show you some examples where you have a pulse of quartz rich, then you have a pulse of sulfide rich, then you have a pulse of quartz rich, then a pulse of sulfide rich, and then maybe, some gold. So what the normal situation is, the first ones are gold poor and quartz rich. The next type of solution that as the thing tends to change over time, the solution becomes less quartz and more sulfides, and the sulfides tend to be more gold rich. You got some gold along with the sulfides because the sulfur is carrying the gold. But then the last, in the richest districts, you have these last solutions that are pretty much just gold rich. They're super rich in gold. And so you get the last thing deposited in the vein is the gold. And I have examples of this, and I've seen other people find things like this, but I found one time, and it's a little piece, but it has a half an ounce of gold in it. And so it could have been in my handful, but it wasn't. It was another big piece that I found, but it's a little tiny quartz vein. It's less than a half an inch thick, okay? And on either side of this, there's a little tiny bit of quartz vein that's maybe 1/8 of an inch thick on either side. But in the middle, like an Oreo cookie, the filling is solid gold. So instead of being cream in the middle of an Oreo cookie, it's quartz on the outside and solid gold on the inside. And these form because the quartz part formed first, and there was some iron because the quartz that I have is very iron stained, and then the last bit of the solution that was coming through was all kinds of gold rich. And so you get this, and it's just a little vein, but it's a slab of gold on the inside. And a lot of times gold does form that way. You get these flat sheets of gold that form from the last phase. And I'll show you some examples of quartz and stuff, and we'll talk about this right now.
Here's a chunk of a little tiny vein from Arizona, and this little quartz vein is maybe only a ½ inch thick and maybe 2 inches long in the longest direction, but you can see it's just filled with gold all through it. And the quartz formed first, and then at the last the gold-rich solution got in there and deposited all this gold. Here's a similar piece from Nevada, a little tiny quartz vein, only this one you can see the country rock, the surrounding host rock, the gray there, but the chunk of gold pretty much fills up the little narrow vein that was between the chunks of host rock. This is a quartz vein example from Western Australia, and the vein's a little bit bigger, of course, but you can see these kind of lines, especially on the right-hand side, lines of gold perpendicular to the quartz vein, and this was a late-stage thing where really rich fluids came in and just filled up the open space left in the vein.
So what are the skills in finding big gold and finding pockets and stuff? Well, there's a whole skill of tracing gold as you go upstream, especially when you're in the upper parts of a drainage, in rivers and bigger drainages and that sort of thing, bigger creeks. You're often going to have multiple sources of gold, and so it's hard to trace any one out because you may have multiple ones here and there, and you can't really tell a difference of where one starts and one stops because there's all kinds of them. But when you're up in the higher reaches of a stream, up in the upper reaches, in the upper part of the drainages, and actually we'll talk about that in a second, but upper parts of drainages are better for big gold. But when you're in these upper parts of these drainages, you can actually find situations where there's only one source, and you literally have gold, 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 and you go up the stream, you reach a certain point, and gold stops, it's gone. It's kind of gets better and better and better, and then a little bit, and then gone. And you then need to turn and go perpendicular to the stream, one side, up the other. You never know, it might be this side or it might be this side that the gold is shedding off of into the ravine bottom, but there's a whole technique of that, and I'm going to show you a little bit more about that right now.
Here is a diagram I have for tracing uphill, finding and tracing gold pockets. This is a tried and true method that's been used in Australia. It's called loaming, but the sense is the same. You've got a gold pocket. This stream would be flowing from right to left, and as you were coming uphill from the left, you would be getting gold, and maybe in the middle below the pocket you'd get a little bit higher concentration, but sometimes that's hard to tell. But eventually you'd go upstream to reach the point that was the upstream boundary of gold, and you'd start to get nothing. And you'll know that either one side or the other, one hillside or the other, would be where the gold was shedding off of. And then you could go up the hill and run a line parallel to the stream but uphill above the stream and see if you get any gold. You do that on both sides, and theoretically on one side you should get gold and the other nothing. And so the one side where you're getting some gold, then you can start making lines parallel to the stream further uphill, and the width of the gold that you're getting in the line above the stream should get narrower and narrower and narrower until you reach the gold pocket. And you have to actually, if you make a line above the gold pocket, you should cross across there and get nothing. And so then you drop back down until you find where the gold is shedding off of. And a lot of times, the coarsest gold, the biggest gold, which is what we're talking about in this video, is going to be the gold that's right at or just below or in the immediate area of the pocket itself.
So how do you get yourself into places like this? Well, you're going to have to research, because there's districts that really all it produces is fine gold, and some districts where the biggest nuggets are just like little tiny pickers. But there are other districts that are known for coarse, big nuggets. And all the places that I showed you the gold from, they're all places that are known. Places where I've found big gold are places where the old time reports of it said, yeah, there's coarse gold here, big nuggets, you know, half ounce and ounce and that kind of stuff. And so, you know, you're going to be doing research in reports, and I'll talk about that briefly right now.
All the bigger gold I've found, and pretty much all the bigger gold that I know of other people having found, has come from districts that are known to produce coarser, bigger gold. You know, if you go to a district and the description of it is, oh, everything from this district is fine gold. And, you know, there's nothing wrong with fine gold. It does add up. But, you know, if you're looking for big nuggets, you want to look in a place that's known to have big nuggets. And you find that out by reading reports and books. This book, Gold Districts of California, has, you know, many pages of descriptions and includes, you know, notations. Oh, yeah, this district produced nuggets of up to 50 ounces and that kind of stuff. And, you know, that's the information you need. And you can download this book for free. You search on the internet on Google, you can find it for free. There's also Placer Districts of Arizona, a separate book, Placer Districts of Nevada, and another one of Utah, and another one of New Mexico, all of which are written by Maureen Johnson. They're USGS books. Those also can be downloaded for free. So, you know, there's information out there, and if you want to do some research and find places with big nuggets, that's the place to start.
And then another thing that I want to talk about is residual gold. And that kind of goes with the tracing that I mentioned a few minutes ago, where, you know, the gold sheds right off the quartz or shear zone or other deposit that the gold is coming out of the side of a hill. And as it sits there before it really moves down into a drainage and starts its, you know, its journey downstream, you have residual gold. And I've had great luck in residual gold areas. A lot of desert areas can be residual, but in the mountains, even in California, I've found some nice residual areas. And so residual gold, because it hasn't had a chance to be pounded up or broken up or anything, you have a better chance of finding some coarse gold if you're in a district that produces coarse gold. So let me show you a little bit about residual.
The big heavy stuff tends to remain near its outcrop or near the place where it comes out of the ground. The force of gravity, and water and wind and whatever, it takes a lot to move it. Big gold is dense and heavy, and it doesn't want to move unless there's really some force that's making it. And so that's why it tends to remain near the spot where it comes out of the ground if it can.
And next I'm going to come back to upstream sources. I mentioned earlier on when we were talking about the tracing is that upstream sources are better for coarse gold than rivers and lower creeks down into the system. And it's not that you can't find big gold in a river or downstream, because certainly that's been done a lot. But the truth is that the amount of stream energy, water flow energy pushing gold and gravel and rocks and boulders, the amount of energy that it takes to push a half ounce nugget or an ounce nugget down a stream is a lot more energy than it takes to produce, say, a quarter of a gram little picker nugget downstream. That a lot less energy will blow that quarter of a gram picker nugget on down. And I've actually been to places, I know people who've been to places where they hardly found any small gold, but they found big gold. And it's wise because the energy of that stream blew the small stuff downstream. It's down there, but the big stuff, it just didn't have enough energy to really move it. And so, it takes a big storm, a big flood, big energy in the river to push a big nugget downstream. So that's why upstream sources are generally better. Like I say, there's plenty of exceptions where, in rivers you can find big gold. Now, whatever you're looking at, whatever your quest for big gold nuggets, and I hope you find a fistful of them, whatever it is, it takes knowledge and skill. The more you know about the geology, the more you know about the kinds of deposits, how it works, how to use a metal detector or sluice box, or whatever tools you're using, dry washer, whatever you're using. The skill is what makes the difference. The knowing what you're doing is what makes the difference. And so I wrote a book. It's called Fistful of Gold because, hey, that's what I want you to find is Fistful of Gold. And it will help you get the necessary skill and knowledge so that you can go out in the field and be successful finding gold. And I'm going to tell you a little bit more about my book right now. This is my book, Fistful of Gold. It's an encyclopedia of everything you need to know to go out and find gold for yourself. It distills down my 45 years of experience out in the field prospecting, as well as my degree in mine engineering. It's, like I say, an encyclopedia. There's a lot to it. It's over 250,000 words long, hundreds of pages with hundreds of illustrations, teaching you what you need to know about geology, about mining districts, about techniques of finding gold. It covers metal detectors, sluicing, panning, dry washing, high bankers, you name it, it's covered in there. It talks some about platinum and diamonds, but it's mostly about gold because gold is more widespread. It is not so much a book about where to find gold, but a book about how to find gold. Because even if you have a location where gold was mined in the past and you go out there, well, where should you look to be successful in your prospecting, to find the gold that's there? This is the book that's going to tell you that information. I spent most of 10 years writing this book, so I thought a long time about it. It's got, like I say, lots of information and lots of illustrations, and I've had results from people who bought it. It's available on Amazon, but I recommend buying it through High Plains Prospectors, and I'll put a link in the description for buying this book through them. They have a better price than Amazon, and I have a special deal that I'll tell you a little bit more about, where you can get a 5% discount from the price even with that. On Amazon, the book rates a 4.7 out of 5, which means that of all the people that have bought it, they've been really highly satisfied, and I think you, if you buy my book, will be just as highly satisfied as well. Now let's talk a little bit more about High Plains Prospectors. They're a prospecting shop, a mail order prospecting shop that I've partnered with. The deal is that I can get you a 5% discount, a coupon code, and I'm going to put the code to that right here. It's just Chris Ralph, all caps with no space between Chris and Ralph. You put that in there as a discount code and you'll get 5% off their already really good prices. I think it's a great deal where you win by getting a discount, I get a little percentage of that, and they get new business. So if you need prospecting supplies, High Plains is really the way to go. And I'll put information, like I say, in the description more about how you can work with them, because I'm working with them. They really are great guys, a great company. For even more information, I also have a website, and I'm going to show you my webpage and talk a little bit more about that right now.
This is my webpage. It's located at nevadaoutbackgems.com. You can Google it, or I have a link down in the description below. But there's lots of information here, miscellaneous stuff, pictures, some historic information as well, stories. It's got a lot of great fun stuff. You'll probably be interested in it.
Now, on all of my YouTube videos, I encourage you guys to ask questions. If you have thoughts, comments, suggestions for things that I ought to look at in my videos, things that you want to find out more about, and I answer 100% of my questions. There's not very many YouTubers out there that answer 100% of their questions. I'm one of the few. And so I will do my best to answer what you have. I mean, I only can write so much. Sometimes the answer is something where I'm going to recommend that you buy the book and read about it. I also ask that you subscribe to my channel, click the bell notification so that every time I come out with a new video,
and you'll be able to watch it. And like I say, I cover a huge amount of topics. I also have 250 videos that I've already done, and so you can go back through my catalog of videos on YouTube. I'm sure there'll be many videos there that you'll want to take a look at, especially if you have any interest in gold or platinum, diamonds, gemstones, geology, and that sort of stuff. My YouTube site is going to be right up your alley. So I'll see you again real soon. We'll be out in the field and back in the office at the whiteboard, and whether we're looking at gold or platinum, diamonds, gemstones, or other interesting geology, it's going to be fun. You're going to enjoy it, and we'll see you again real soon.